Hello students, today now I will start soaps and detergents concept. Okay, soaps and detergents concept, it is very important for your board examination. Now we will see the content of this video. Okay, now I will explain you about soaps and examples and structure of soap and cleaning action of soap. Okay, first we will see the definition of soap. Okay, soaps are nothing but sodium and potassium salts of long chain carboxylic acids. Okay, sodium soaps are nothing but if there is a sodium ion, those are sodium soaps. If there is the potassium ions, those are called potassium soaps. These are having the sodium and potassium salts of long chain carboxylic acids. Okay, soaps are sodium and potassium salts of a long chain hydrocarbon compounds, means these containing one part is hydrocarbon part and another one is a ionic part, okay, of a carboxylic acids. Carboxylic acids nothing but COOH, it is a carboxylic acid. This COOH, it is also known as a fatty acids or vegetable oils. Okay, these are extracted from vegetable oils. This part in where H it is removed and there is a Na plus will attached in soaps and K plus will bonded to the COO bond. Okay, next these are the composition of large non-ionic hydrocarbons group and ionic group. Okay, see here, this is one part is a hydrocarbon group and another part is a sodium group, means ionic part group. So okay, this part is a non-ionic in nature and this is ionic in nature. Okay, I will explain briefly about this in next slide. See here, for examples of soap, the sodium stearate, it is a best example. See here, C17H35 COONA, it is a sodium stearate in where this part is a non-ionic in nature and this part is ionic in nature, because here Na plus, it is a ionic compound, that is a metal compound, ion that is attached to COO. This part is ionic in nature and this part is non-ionic in nature. Okay, now we will see the structure here of a soap particles. So in sodium stearate, this part is a C17H35, it is called a part, it is a B part. This A part, it is called tail part, and this part, that is ionic part, is a head part, and this C17H35, that is a organic part, that is represented as a zigzag in manner. Okay, next this ionic part COONA, that is represented as a head in shape. Okay, next the main part is to explain here is this zigzag part or a tail part, it is known as a hydrophobic part. This hydrophobic part, it is known as water repelling end, means this part which C17H35, that is the organic part, that will not dissolve with water, and this part, that is ionic part, will easily bond with the water and dissolve with water. So it is a water attracting part. So water loving part is called hydrophilic part, water repelling part is called hydrophobic part. Okay, see here, this is looking like a tadpole shape. So the soap molecules or soap particles are having the tadpole shape. Okay, I am revising here again. See here, this part, the zigzag part, that is long hydrocarbon part, it is water repelling end, and this head part, it is water attracting end. This water repelling end, it is called a hydrophobic part. Here the head part is hydrophilic part. In head part there is a COONA plus, in a tail part there is a hydrocarbon, that is C17H35 part is attached. Okay, next we will see the suffonication concept. Okay, in suffonication concept, it is the process of making soap by hydrolysis of fats and oils with the alkali. This is a concentration hydrochloric sodium hydroxide which react with the fats or oils that will form easily soaps plus glycerol. This fat or oil, it is nothing but hydrocarboxylic group, that is COOH, and when it is react with NaOH, it will form COONA, that is ionic part group. Okay, what do you mean by suffonication? Suffonication, it is the process of making of soaps by hydrolysis process. This reaction or this process is called hydrolysis process of fats and oils with the alkalis. The alkali used here is concentrated sodium hydroxide, and we can easily get a soaps, and along with the product is byproducts are glycerol. Okay, next we will see the cleaning action of soaps. Okay, see here in cleaning action of soap, first this is the yellow shape, it is nothing but a grease oil which is attached to the cloth. Okay, in cloth there is a glycerin oil, grease oil is attached. Okay, when we are dipped or mixed cloth with the water along with the soap, the reaction will takes place, means the soap molecules will easily bond or forms spherical molecules with the grease. Okay, how they will form that spherical molecules, that is how they will react with grease oil or dirt, that we will see here. Now the soap molecules, that is the one part, it is a ionic part, that is COONA plus, and other part is a hydrocarbon part, that is non-ionic part. That non-ionic part, initially I told, that is a hydrophobic part. The hydrophobic part will never dissolve with water, they will directly bond or dissolve with the grease oil, that is the grease oil, they will directly dissolve with grease oil. And ionic part, that is hydrophilic part. Initially I told hydrophilic means water loving part. This water loving part is directly dissolved with the water, and another part, that is non-ionic part, it is directly dissolved with the grease oil, that is dirt which is attached to our cloths. When number of soap molecules are bonded towards all with the grease oil, there is a formation of a spherical shape like structure. That spherical shape like structure are called micelles. Okay, here we will see the definition of micelles. A spherical aggregate of soap molecules is formed in the soap solution in water and is called a micelles. Micelles are formed by the bonding of dirt or a grease oil with the non-ionic part and the ionic part that will bond towards the water end. Okay, by this there is a formation of a spherical aggregate of a soap molecules, that is called micelles. When the soap molecules thus helps in dissolving the dirt, by this process, by this action, these soap molecules will helps to dissolve the dirt in water, and we can wash our clothes clean easily. Okay, by when the soap molecules form the spherical aggregated micelles, we can easily remove the dirt or grease oil from the cloths when we rinsed these cloths in water. Okay, see here in your textbook they have given that there is a hydrophilic part and one is hydrophobic part. Hydrophilic part is ionic part, hydrophobic part is non-ionic part. This non-ionic part is directly bound to or dissolved to the grease oil which is attached to the cloth. Okay, and this is the oil that is attached to non-ionic part, that is hydrophobic end, and another one is hydrophilic end, that is bonding towards the water. Okay, here it is the formation of a micelles. See, this is a micelle which is after brushing of the cloths, we can easily remove this micelles from the cloths and we will get our clean shirt from this action. Okay, by the soaps. See here, this is the steps I am given here for what is the cleaning action of soaps. Just you have read these points and revise the concept, you can easily understand the cleaning action. Okay, the first thing you have to remember is ionic part, non-ionic part. Ionic part dissolve with water, non-ionic part dissolve with grease oil. Okay, when these will acted in on the shirt or a grease oil, there is a formation of a there is a formation of what? Micelles, that is spherical aggregated soap molecules. These soap molecules will remove the grease oil easily after the brushing on cloths. Okay. See here, I am giving one more image here to understanding purpose. Okay, this is the cloth and this is the dirt, which is the soap molecules are acting on the dirt or a grease oil, the soap particles. This is the head part, that is ionic. This is tail part, that is non-ionic, which is bonding towards the dirt. After the rinsing, this molecules means this micelles will removed from the cloth. Okay, I hope student you are understanding the cleaning action of soaps and the introduction of soaps and examples of soap and structure of soap. Okay, thank you, and subscribe and like for our easy classes YouTube channel. Okay.